This is part 2 of our video in section 5.5. This is the triangle inequality theorem. Not every group of 3 segments can be used to form a triangle. The lengths of the segments must fit a certain relationship. For example, 3 attempted triangle constructions for sides with given lengths are shown below. Only the first set of side lengths form a triangle. So we can make a triangle with side lengths 2, 4, and 5. But we can't with 1, 2, and 5. So if you're not sure what these circles are doing, if this vertex is the center of each circle, this would be a radius of 1. So this side could move anywhere in these spots to connect with this side. And this side obviously can do the same. It can move in any of those spots to connect with that side. But notice how these circles never overlap. If they don't overlap, then it means these sides can't touch. No matter how hard you try, these sides aren't going to touch. The problem is this side is too long, or these sides aren't big enough. Now, if you look at where these circles intersect over here, they intersect where a third possible vertex could be. That's why that does make a triangle. Now, notice how you can't make a triangle with 1, 2, and 3 as well. They do intersect, but they'd intersect right here on this segment. So it's not going to make a triangle. It would just look like a segment. So why doesn't that work? Again, it's either this guy's too big or these guys are a little bit too short. So that's what we're looking at here. Theorem 5.12 is a triangle inequality theorem. It says the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So really, you should technically check 3 inequalities. But really, what that means is if you take your 2 smallest sides, like on this triangle, for example, your 2 smallest sides would be the red one and the green one. If you add your 2 smallest and they're bigger than the biggest, then that would make a triangle. Because obviously the 2 biggest are going to be bigger than the smallest and so on and so forth. Let's try some examples. So in other words, here's another way to state the theorem. If the sum of the 2 smallest numbers is larger than the biggest number, a triangle could have those side lengths. Could a triangle have these side lengths, 5, 4, and 8? Well, the first thing I'm going to point out to you is make sure that your side lengths are in order. And these really aren't, but it's not going to hurt you because that's still the biggest. 4 plus 5, is that bigger than 8? Yes or no? 9 is bigger than 8. So yes, that's a check mark. That would make a triangle. 7, 3, 6. Watch yourself. Make sure you add the 2 smallest. 3 plus 6. Is that bigger than 7? 9 is bigger than 7. Yes. Add your 2 smallest. 8 plus 10. Is that bigger than 12? 8 plus 10? Definitely bigger than 12. That makes a triangle. 4, 13, 23. Add your 2 smallest, 4 and 13. Does that give you something bigger than 23? Well, 4 plus 13 is 17. That's not bigger than 23, so this would be no. Can't make a triangle. 1, 2, 3. 1 plus 2 is 3. It's not bigger than 3, so I'm putting a slash through there. When you put a slash through, that means it's not greater than. That doesn't make a triangle either. 26, 34, 52. 26 plus 34. Is that bigger than 52? 26 plus 32 gives you 60. 60 is bigger than 52. That will make a triangle. Big part of your assignment is on this triangle inequality theorem. Here's another situation. We want to find a possible side length. A triangle has one side length of 12 and another side length of 8. Describe the possible lengths for the third side. Well, maybe that x is the smallest side of your triangle. So maybe it would be less than 8. Or maybe x could be the biggest side of your triangle. In that case, it's going to be bigger than 12. Your answers could be small, they could be big, they could be somewhere in between. There's going to be a range of values here. Here's how you do these problems. When they give you two sides, that third side needs to be bigger than a number, and it needs to be smaller than a number. Now, where do those numbers come from? Well, I'll put the two numbers in and see if you can guess. The third side better be bigger than 4. Over here, this third side better be less than 20. Where did I get those two numbers? 12 minus 8 is 4. 12 plus 8 is 20. This is your range of values. What if x was 4? If x was 4, 4 plus 8 is not bigger than 12. X cannot be 4. It's got to be bigger than 4. So like 4.1 or 4.7 or 4.03, those answers work. It's bigger than 4, not bigger than or equal to. Also, x needs to be less than 20. It can't be 20 because 12 plus 8 is not bigger than 20. But if it's less than 20, like 19.9 or 19.2, then that works. Your x values, the third length, needs to be in between these two values. Bigger than 4, but less than 20. So let's find possible side lengths. A triangle has one side of 11 inches and another of 15 inches. Find the lengths of the third side. Well, I know that my third side needs to be bigger than the difference. 15 minus 11 is 4. And my third side needs to be smaller than the sum of the two, 15 plus 11.